When you're running systematic experiments in Galileo, it allows you to quickly spot any errors or regressions with your agent in a safe and controlled way. You can see here in this experiment, I have the input that the user provided, then the output here provided by the model or the agent, and then all of these built-in metrics that help me figure out where my agent is failing and what inputs and resulting outputs are causing those failures. So I can sort perhaps by whether or not the action advancement, whether or not the agent was able to move forward with answering the user's request, and look at the ones where it's not handling it very well. Datasets and experiments are very closely intertwined. And at a high level, what I just mentioned is you can catch regressions before they hit production with experiments. So you can iterate on prompts and models, run experiments against your datasets without having to rebuild your entire application pipeline. One of the key concepts is to be able to integrate this with your CI/CD pipeline so that you automatically kick off experiments in Galileo and just fail your pipeline if certain metrics are going below a threshold. Out of the box, and custom metrics you can create that are custom to your application. And then we're going to talk about datasets right now in terms of how you can create datasets in the UI using code and creating version datasets of this so that you can, again, systematically test your agent. So the agent that I'm working on is an agent that a field tech assistant might use in the field. They're working with a customer and the customer has a problem with their AC unit. This is an agent that the field tech could talk to help answer the customer's question. So let's go back into the UI and start playing with the dataset. So if you don't have a real dataset from actual customers, in this case from customers who have issues with their home appliances, you can create a synthetic dataset straight from the console. So if I click on create dataset, I'm going to click on auto generate test dataset. And the first thing I'm going to do is select the model. This is use GPT-4o mini. Let's provide a few examples for the model so that I can create some test examples based on a few shot approach. So I have a few examples here. First one is the customer's AC has a power shortage. I need to figure out which capacitor to use. And then the second example will be the customer has issues with their fridge. And then you can further customize the dataset to give the model more nuance about your application. So I'm going to say this is an application that is helping field service technicians, blah, 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 helping customers in the field. Down here, I'm going to select, just to create a more varied dataset, I'm going to say general query. I'm going to say toxic content in the query. And let's say some things are off topic, because when your agent is talking with actual customers, they're going to provide all kinds of input that are not related to what your agent's meant to handle. So this is a quick way to create some just really random input. I'm going to make this, let's say 50 rows of data, hit generate, and let's see what the model comes up with. All right, here's the full data set. You can see in the metadata, some of the inputs from the customer are toxic, some are general. There should be some off-topic ones to give you an idea of what these inputs or customer inputs look like. Customer 4x2 dishwasher is making a loud grating noise. What's going on? If I go down here, this is some more toxic stuff. And then down here is just off topic, I believe. Yeah. Can you recommend good sci-fi movies? So we have a really kind of varied data set that we can represent as what real customers would say. Now, if I look at the actual agent that I'm going to run this experiment on, the system prompt looks similar to what I had put in Galileo. It's a home field technician assistant. It has access to this tool called lookup customer, and I provided an array of some just random customer data. And if I run this agent, it's just going to give me the output of this prompt. This is one single input, lookup customer C1001, AC isn't working, what should I check first? And it should give me a pretty generic response up here. So I was able to find the customer, and here are some just general things I should do. Now, let's actually run the experiment. Out of the box, I'm going to have Galileo create some metrics for me, tool error rate, instruction adherence. And I also want to look at input toxicity, because if you remember in my dataset, I had created varied inputs. Some of them are indeed toxic. And I'm going to log this into my ATC demo project. All right, let's start running this experiment now in the terminal and see what the output looks like in the console. And it's now looping through those 50 rows. creating an LLM output, and then also attaching all of these metrics to the experiment. The experiment completed. Now I'm going to go back to the console to see the results of my experiment. This is the Home Services V2 experiment. And if I click through here, I can see the full input from that data set that I created, which was synthetic, and also all of the associated metrics that came out of the box that I defined in my experiment code. If you remember, we had some inputs that were toxic, and that's why this input toxicity metric is 100%. This input used the term idiots, and you can filter through, sort through this list just like you would in a kind of spreadsheet manner and try to figure out which inputs and outputs led to metrics that weren't aligned with what you were expecting. And at the top, you'd see the high-level metrics across the entire experiment. If I go back one level, I can now have a whole list of experiments and start to compare which experiments with which data sets were above or below certain metric thresholds that I've set for my application. So that's how you can compare and contrast different experiments, data sets, all within one unified platform in Galileo.